Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy, and today we are looking at our last video in the basic algebra series on problem solving using equations. Now don't worry, there'll be more complex algebra, but they'll be in another playlist for advanced algebra. Now in this video, we're going to do some problem solving that you might see on an exam. So there's some assumed knowledge that's going to go into some of these questions. The assumed knowledge might come from geometry that you've studied earlier in the year or in a past year, or measurement questions. And you might be thinking, well, that's not fair. The exam's on algebra. Yes, but it is assumed that you actually learned this content either earlier in the year or in a previous year. So it's knowledge you should already have. And that's why it becomes problem solving, because it's combining knowledge from across different strands of mathematics. Now, this is why it's a good idea to do your homework and to try and do all the questions in a chapter. Even if your teacher only assigns you maybe the first couple of questions from a chapter in your textbook, it's a good idea to jump down to later in that chapter and look at some of the problem-solving questions, because that's where these types of questions typically come from. Okay, so that was a little teacher lecture there. All right, let's look at our first example. The diagram below is a rectangle not to scale. Now, the reason why they tell you it's not to scale is because you might be tempted then to go and get a ruler and try and work out x is from a ruler. So when it says not to scale, it means don't bother about using a ruler. It tells us that all the measurements are in centimetres. Now, that's a clue as well. It wants us to give our answer in centimetres at the end. Now, what we need to do from this question is determine the value of both unknowns and hence the area of the rectangle. Now, a lot of students will get this far and have a little bit of a mental freak out because they're thinking area of a rectangle. We haven't studied area of a rectangle. As I've just mentioned, it's assumed that you know what the formula is for the area. So this is the part of the question where I'd be getting my highlighter out and I'd be highlighting the important information. I'd be highlighting things like centimetres to remind me at the end to present my answer properly. And also, I'll be highlighting area so that I don't forget that I've got to find that out at the end as well. So firstly, let's think about what we know about rectangles. Rectangle properties are things we should know. We know that the opposite sides are equal. So that means that this top of the rectangle will be equal to the bottom of the rectangle. We can make an equation out of that. And we also know that we could write that as x minus 7 equals 8. Because these sides are equal. And we're going to have another side. The two sides are going to be equal as well. So that means y plus 5 is going to be equal to 12. So now we've got two equations we can solve. So let's do it. So firstly, on the first equation with the top and the bottom of the rectangle, we're going to add 7 to both sides. And we'll get x equals to 15. And we'll do the same on the right-hand side as well. We've got take away 5 and take away 5, and then we're going to get y equals 7. So now we've got values for x and values for y. Now, we don't need to necessarily work out the area of the rectangle using the algebra. What we can do is use the 12 and the 8. They're given to us, so we know what the two sides are equal to. We can actually work that out. So now let's find the area of the rectangle. So what we're going to do is remember that area equals length times width. It's a good idea to write that as a formula. Sometimes that's worth the mark. 8 times 12 is equal to 96 centimetres squared. Now that's where the centimetres came in that we highlighted at the beginning of the question, because we need to present our area answer using the correct units of measurement. And for area, that's a power of 2. That was our first worked example. Bit of prior knowledge there, how to find the area and also how to find the fact that opposite sides of a rectangle are equal. Now, you could have had some success with that question even if you couldn't work with algebra. If you knew your area formula, you could still find the area without the algebra. Okay, let's look at worked example 2. The diagram below is a triangle. Fancy that. It's not to scale again. So that means don't get your protractor or your ruler out. We need to find the value of y. So once again, some prior knowledge here. That prior knowledge is that sum of angles in a triangle is 180 degrees. Now, if you don't know that, hopefully your teacher wouldn't have put that in the exam if you weren't at a level where you should know that. But I'm fairly certain that's taught in Year 7 and 8 geometry. So that's why this is a valid question for an exam. So if the sum of the angles equals 180 degrees, therefore 3y plus 2y plus y, they're the angles, will equal 180 degrees. So now we've got an equation that we can solve. So let's add the 3y plus 2y plus y. We're collecting like terms there. That will give us 6y equals 180. and therefore if we divide both sides of the equation by 6, we get y is equal to 30 degrees. Don't forget your degree symbol at the end because you found the value of y. And our final example today is also another rectangle. We need to find the value of x in the rectangle shown, and we're told that the perimeter is 140 centimetres. Now, if we have a look at this particular rectangle, we've got what we knew from before is that opposite sides are going to be equal, and opposite sides here are going to be equal as well. So we've got 2 of those and 2 of those. And we also know the perimeter means sum of all sides. So what we're going to do is we're going to add the 4 sides together, and then we're going to collect like terms. So I'm told it's equal to 140, and I've got 2 sides equal to x minus 14 and 2 sides equal to 2x plus 9. The reason why I've used brackets is it's a little bit simpler, 2 times. Alternatively, you could have done 140 equals x take away 14 plus x take away 14 plus 2x plus 9 plus 2x plus 9. That would have been valid as well. Okay, so let's expand those brackets now. 2x take away 28 plus 4x plus 18. So that's made it a little bit simpler. The reason why I did the brackets as well is just to make sure that the plussing and the minusing all through the equation gets done properly. Okay, so we're going to add these together. I've got 2x plus 4x. Now we're still collecting those like terms. So 2x plus 4x equals 6x. Negative 28 plus 18 gives us negative 10. Be very careful with those negative numbers there. They will always trick some people up. Now I need to take this negative 10 to the other side of the equation. So I'm going to add 10 to both sides. That gives me 150 equals 6x. Divide both sides by 6 now, and I get x is equal to 25. So now I found the value of x in the rectangle shown. So problem solved. I should also then substitute that back in at the very end and just double check that when I add all that up together, I get 140 centimetres. Well, did you find today's video helpful? You can engage further with us here at McClutchy Maths by liking and subscribing and hitting that notifications bell so you'll always know when the next video is available. You can follow us on social media. We're on Facebook and Instagram. You can tell us in the comments how you found the video and if it was helpful to you. If you've got anything more detailed that you need to know, any questions, or you want some help with an algebra problem, send it to us at mcclutchymaths@yahoo.com. Well, thank you so much for watching today. I'm Natalie McClutchy. Have a wonderful day.